Welcome everyone. My name is Lars Gregersen. I'm going to talk to you in this webinar about LiveLink for MATLAB, and we just have 80 minutes for covering it, so we're going to be brief about some of the minor details. I'm going to give you a very short brief overview about the COMSOL Multiphysics world and how our software is connected together. And I'm going to tell you how LiveLink for MATLAB fits into our other tools that we have as part of our product suite. Using LiveLink for MATLAB, you have to use the COMSOL API, where API stands for Application Programming Interface, and that is the method you use to communicate from MATLAB to COMSOL and make COMSOL do things based on the MATLAB scripting language. Using the COMSOL API can sometimes be tedious and complicated, and for that purpose we've created some wrapper functions that I'm going to introduce to you at the middle of my talk. I'm going to do a live demonstration how those work. Those take a lot of the commands you have in COMSOL API and combine them into a set of easy-to-use MATLAB functions that provide a lot of functionality for the most common usages that we see people using LiveLink for MATLAB for, and also takes care of the conversion of data types in COMSOL into data types that are easy to work with in MATLAB. And we have something called model M files that can take an entire model made in COMSOL Multiphysics and turn that into an M file that you can study using the MATLAB language. You can of course modify this M file and run it again and use that for setting up models and learning about the syntax for the COMSOL API. And at the very end, I'm going to show you briefly some tips about how to get started using all of this. If you look at the COMSOL Multiphysics suite of products, you can see in the middle you have COMSOL Multiphysics here and the model builder that you use to set up a model. And based on your needs, you either have one or more modules that can be used to set up the physics that you need for your modeling efforts. Many users will require extra data, either in terms of functionality from MATLAB or Excel, or in terms of the LiveLink that we have for many of the different CAD programs that we interface to. And you can use all of those together with the physics to set up the model that you want. Once you have done that, you can turn your model into an application. An application takes something from a model and a user interface you put on top of that model and combine that with visualization and reporting to make sure that people that are not trained for creating models and are not trained necessarily for doing models in COMSOL Multiphysics, they can now use your model by the way of user interface that you have created by a simplified app usage. And you can take your app and deploy that app such that people that want to use your app can use it directly from a browser, or they can use it from the Windows client or from a tablet. And you can deploy your app on the COMSOL server infrastructure, which means that anyone in the world can have access to your app if you give access to that app. That makes it very easy for you to disseminate your work between your colleagues, customers. If you have customers using your app, you can even sell your app and the functionality in that. And of course, in your entire company or university, you can give access to the functionality of the app, no matter whether or not people are working in research, in engineering, or directly in production. If you look at the many products we have in the LiveLink group here, you can see that we have LiveLink for MATLAB and LiveLink for Excel that are both into numerics and the way that you work with numerical data. We also have a lot of interfacing products for CAD in the interfacing group. And actually, no matter what type of model you're creating using multiphysics or one of the many physics modules that we have, you can use LiveLink for MATLAB and one of the CAD products to control COMSOL and the geometry that you have in the CAD program to define the geometry, set up your model, solve the model, and extract data to MATLAB for further processing. If you look at the functionality in LiveLink for MATLAB, it's a bidirectional interface between MATLAB and COMSOL Multiphysics. That means that you can send data and commands from MATLAB to COMSOL Multiphysics. COMSOL Multiphysics will do its computations, and you can then extract data back into MATLAB again, either numerical data or plots for visualization that you can use later on. COMSOL works on Windows, Linux, and Mac, and so does MATLAB, so do we. So the interface goes between Windows, Linux, and Mac, and you can actually have a connection from, say, MATLAB on Windows and COMSOL Multiphysics on a Linux computer if you want to have that. And we always support the latest 2 versions of MATLAB at any given time when we release a new version of COMSOL. That means that currently for 5.2a we support MATLAB 2016a and 2016b. Those are the ones that we test and know that work. You should also expect that versions that are slightly older than that, that they should work as well, maybe with some degraded functionality or sometimes degraded performance. So what are people using LiveLink for MATLAB for? Well, these are just some of the examples that we see people using LiveLink for MATLAB for a lot. One thing is pre-processing of data. Before you start modeling in COMSOL, you might introduce images data, data from experiments, numerical data that you have from other sources like databases, and you can include that data inside your models. Once you have solved your model, you want to extract data again from your models, either in a numerical form that you can use for your own plotting and further processing in MATLAB, via MATLAB's own language or the many toolboxes that you have access to there. And you can, of course, visualize things in MATLAB a lot, so you have access to full plotting. So any plot that you can create in COMSOL Multiphysics, you can recreate that plot inside of MATLAB as well. All aspects of your model and all settings can be manipulated using the MATLAB command line or MATLAB scripts. So anything that you want to tweak, you can use the MATLAB language for doing it, say geometries, meshes, physics settings, or the entire solution scheme for changing your model, solving the model, and extracting data again. Using MATLAB means that you can, of course, have access to all the toolboxes that MATLAB provide, but also you can use MATLAB as a glue between COMSOL Multiphysics and other simulators or solvers or optimizers, depending on your needs. So you can take data from COMSOL Multiphysics, tailor that in certain ways, put that into other simulators, make those simulators do their work and extract data again and put that into COMSOL if that is what you need. So using MATLAB, you can interface anything you want, making sure that you can interface in all directions. And similar to creating apps in COMSOL, you can create graphical user interfaces in MATLAB, which give access to the full MATLAB language and all the things you can do there just in a graphical form. And you can, of course, send those graphical user interfaces to other users that have access to COMSOL and MATLAB for their usage. And one last thing is that you can define model settings using MATLAB functions that are then called while solving by the COMSOL solvers, which means that you have very advanced things. Then you can, for instance, thermodynamics or things that you need to solve. If you want to look up things in a database or extract data from an external source in real time, you can use MATLAB functions for that while solving. So this is a picture of how things work. You start off MATLAB, and MATLAB creates a connection between the COMSOL Multiphysics server. And even though this interesting, non-interesting windows is looking like a command window or DOS box, this is where the entire model lives. So anything that you send from MATLAB is actually executed in this window, and once you extract data from this window, it goes into the MATLAB workspace. And actually at the same time, you can connect from COMSOL Multiphysics to the same COMSOL Multiphysics server and having access to the exact same model as you have access to from MATLAB, which means that when you change a parameter from MATLAB, it will be immediately visible in its changed form inside of COMSOL Multiphysics. So if you're familiar with COMSOL, this is how things look. You have the model tree inside of COMSOL Multiphysics here with all the settings. And for each part of the model tree that you see here, there's a corresponding part of the COMSOL API that shows you how to set things up. In this case here, we see that we can set a parameter L to 9 centimeters. We set up some geometries, some physics, and so on and so forth. Of course, learning all these commands take a lot of time, so at the very end I'm going to show you how to do this automatically so you don't have to read all of our manuals in order to set up your first model. The idea behind using LiveLink for MATLAB and the COMSOL API is that you have access to a lower level set of information from your models, and for getting access to that using the mphnavigator, which have a similar model tree as you see in the COMSOL Desktop window, but also have all the properties that you have access to using the COMSOL API and all the methods you can call on all the different parts of your model. So let me just show that in a brief live demonstration. I'm going to show you a demonstration using our bus bar model. If you have been to one of our introductory seminars, you'll have seen this model before. I'm briefly going to show you how it works. We have a metal bar here made of copper, and we're going to introduce some voltages here and a ground plane there. So it's going to conduct electricity, it heats up, and we're going to focus on how much this is going to heat up when we look at that. And just clicking down here, you can see that it gets hot here and slightly colder on the other parts of the model. So let's see how this looks inside of the MATLAB interface. This is MATLAB. I have started up COMSOL Multiphysics server, and I'm going to open up a model by the command using mphOpen. So all the commands that we created using that we call wrappers start with the letters mph. This makes them very easy to identify and also avoid any clashes with other functions that you might have access to. In this case, I'm going to load the bus bar model and I click open. The mphOpen command remembers all the models that I've loaded, which makes it very easy for me when I'm working with models that I'm regularly working with to reload them again. So now I've loaded the model. I can show the geometry. So in this case, you can see you have the bus bar model inside of COMSOL. I can show the mesh. You can see that we have a mesh here, all made of tetrahedral elements. And I can show the results. So this is exactly the same plot as you saw before in COMSOL Multiphysics. If you want to learn more about the model, I can start the mphnavigator. The mphnavigator will start up and look at the different settings that I have in my model. And I can navigate my model by looking around in the tree here. One of the things I'm going to look at now is the parameters that I have in my model. In this case, I can see I have a parameter L that is 9 centimeters. That is the length of this part of the model down here. And I can change that. And of course, I've never seen this before, so let's pretend that I want to change this, and I haven't written any manuals. I can then click on this parameter and click here, copy set. And that will copy the command that I need for setting this parameter later on, so I can paste that directly into MATLAB. So let's say I want to change that into 15 centimeters. I change that to 15 centimeters. Let's see if that really worked. I can plot the geometry again. Now we can see that this is longer. I can solve the model. This is the command for solving a certain study. You call the run method on that study, and then this window up here solves the model, and once that is ready, then command is returned back into COMSOL again. And I can then do the plot of the result again, looking at the result. So this way, it's very easy to work interactively with a model. You can change stuff directly inside your model. You can solve the model and extract data again. In this case, this is just a plot. I can do anything with it that I want, so I can use grid commands. I can save the plot as I would normally do with a regular MATLAB plot, or I can use copy figure to copy this into a presentation or report, depending on my needs. So this gives full access to all the plots that I have access to inside of COMSOL Multiphysics directly in MATLAB. I can extract numerical data. We have a function called mphInterp. It takes the model as a parameter, a set of expressions, in this case just the temperature, and a set of coordinates. In this case I have x, y, and z coordinate of the first point, and then x, y, and z of the second point, and they're going to execute this, and I'll extract the temperatures in Kelvin from that point on. And since these points are just a centimeter apart as at this beginning of the bus bar, the temperatures are very close together. If I want to find the maximum temperature, I have a wrapper called mphmax that can calculate the volume maximum of the temperatures inside my model using this command. So this is a very easy way to work with a model. You extract data and you use the wrapper functions that we have in order to interact with your settings in your model and extracting data from the model again. I don't think we have time for answering any questions. I'm trying to follow up the comments that people give here, and we're going to follow up on those later in emails. So please keep posting those questions to us, and we'll focus on those later on. Now I'm going to go back to my slideshow just to show you the rest of the things you can do using the interface. So we saw mphOpen, that used for opening up a model and loading it. We have a similar one called mphsave. You can use for saving a COMSOL model either as an mphs file or as an m file. You can use mphstart for connecting MATLAB to COMSOL server. You can use either a connection directly from COMSOL server on your local computer, or more relevantly, to a server that is on another computer. For instance, a large Linux server that you have in the basement that you have access to. We have geometry functions for plotting geometries, but also for creating geometries, either from images or from STL files or surface data that you have as variables inside of MATLAB. We have meshing functions for showing meshes, but also for extracting data from meshes, so you get quality information for meshes. You can also get all the vertices that you have in a mesh, all the element types and all the element sizes and all the connections between the vertices that you have in the mesh. So this is what we normally call low-level information that you have directly access to. You can modify the mesh inside of MATLAB and put the mesh into COMSOL again if you are doing research in meshing. We have many wrappers for post-processing. You just saw mphInterp and mphplot and mphmax. We also have integration and mean and minimum and maximum. You can extract data from S functions if you're doing electromagnetic studies, and you could do particle tracing studies if you have access to the particle tracing module. Plotting, as I've said, all plots are available inside of MATLAB, so you can combine the data that you have from a COMSOL model with other simulation results that you have, or measured data, or data from other sources. Utilities, we have seen mphnavigator. We also have mphsearch that you can use for searching for expressions and descriptions inside a model. So instead of clicking around in the tree to try to navigate a model, you can use mphsearch to figure out how a model is set up and how things are combined for creating the expressions that you need to modify. We have mphOpen for open up models, and we have the MPH application libraries that you use for accessing the example models that we have as part of the LiveLink for MATLAB product. mphEvaluate is a nifty utility you can use for evaluate parameters directly. You can also use that for calculations using units, and you can use that for unit conversion into other units depending on your needs. You might need to convert models data that you get from other sources into units that are more accessible from your modeling purposes inside the COMSOL model, or you might want to extract data in a certain unit and transform that into other units when you want to show that to other people in a report or sending data to other sources. We have access to the MATLAB function node. If you go into global definitions, you can add a MATLAB function. In this case, we have a heat transfer example, so we have some natural convection and some heat transfer coefficient. Those take some arguments and call MATLAB functions while solving, which means that MATLAB takes care of the calculations and returns the data into COMSOL, which means that if you have really advanced things that you want to calculate that can't be done using mere equations that as you would normally see in a COMSOL model, you can use MATLAB functions, for instance, if you require solving equation systems, external data sources, really advanced data lookup, or just because you have all your MATLAB functions are already defined for all your data needs for the purposes. Documentation, we have a lot of it. I would recommend that if you are new to using LiveLink for MATLAB, that you read the introduction to LiveLink for MATLAB. It is only 40 pages and goes through what I've shown you here today in a much slower pace. We also have the LiveLink for MATLAB User's Guide. It's slightly longer, goes into more detail. Once you've read those, you are ready to go. But at the very end, once you're getting into the details, you might want to read the COMSOL Multiphysics Programming Reference Manual. It's about 700 pages, so you definitely don't want to start there. Why you want to start is that you want to start with using Save As. Once you've created a model inside of COMSOL, that means that you can save any model you have created inside of COMSOL as an M file. You can study that M file in the MATLAB editor. You can figure out how a model is set up, and you can learn from the commands and the syntax how to modify your own models or how even to set up a model from scratch. There's a warning here saying that such a model can be really large because it really saves all the steps necessary to set up your model. So if you have solved your model many, many times, it will include those solutions inside your M file. So before saving, you want to choose compact history, and then save the model as an M file. And compact history will just extract the necessary steps for setting up your model from scratch. This is the workflow. At any given time, you can open up a model, you can update any setting and solve the model and extract data from MATLAB. And you can save the model as an image file that you can open either from MATLAB or from COMSOL Multiphysics, depending on your further needs. So this was all I have time for covering today. If you have more questions, then I'm sure we're going to pick up on it, either from the questions you have already posted in the at the webinar. You can also post questions to comsol.com at contact, and you can also visit our website for user stories and videos that were created for COMSOL Multiphysics, other modules, and also for LiveLink for MATLAB. You'll be sent out a link to a questionnaire, a survey, that I hope that you will fill out at the end of my talk here today. Thank you very much.